Welcome to the OpenAI Whisper and Impractical demo at Cloud Native Media. As you can see from the screen, we are currently transcribing this audio stream to demonstrate the capabilities of Whisper. This is partly to demonstrate the capabilities of OpenAI Whisper, but also because I've recently had a second child, and doing any technical discussion after 5 p.m. is currently beyond me. So let's start. Open presentation. Next slide. What will we discuss today? We're going to discuss what is OpenAI Whisper, what this talk is about, what is an ML model, looking specifically at the Whisper ML model. As this is cloud native media, we'll look at the cloud native aspects of what we're doing today. And be looking at our demo infrastructure, and if we have enough time, we'll be adding in an additional text-to-speech ML model. Next slide. What is OpenAI Whisper? Good question. Next slide. It's an automatic speech recognition system, and it's available for use today. It supports some say 10 different languages. I've looked and it says up to 99 different languages. I'm not sure if they're saying 10 different languages purely are the ones with the highest precision. But also I know a number of companies are already integrating Whisper into their product portfolios. It's highly trained. So it's trained with over 680,000 hours of multilingual content, and it's a very diverse data set, which we'll talk about soon, which is used to improve the accuracy, working with accents, background noise, and technical languages. And one of the most important aspects is it's open source. So it's available on GitHub today under the MIT license. It's trained using Python, but can be imported into multiple different development languages. So before we proceed, I think it's important to ask the next question. Next slide. What is an ML model? Next slide. It's a file. The data which powers the model is serialized into a flat file. So when you hear people talk about ML models and using ML models and transferring ML models, it's essentially a collection of flat files which can be extremely large. So the Whisper ML model, for instance, can scale to 1.7 gigabytes in size. But some can be far greater but equally smaller. Whisper offers a range of different model sizes with various different speeds associated to them, and varieties, different sorts of accuracy associated to them too. So it takes the complex data structures associated with an ML model. You can imagine there's lots of associations, lots of structures, and it flattens it into a format that can be stored and transmitted. And the opposite of that is to download the file and deserialize the structure for use within your application. So an ML model is not an algorithm. An ML algorithm is the application which is fed initial data sets. So the model data is the output of that process. And the model data is essentially a generated program. A program which contains data and prediction algorithms. It's a program automatically created by the ML algorithm to solve a problem. Next slide. So let's look at the Whisper ML model. Next slide. As we discussed, two of the important aspects of the Whisper ML model is the data that was used to train it. The data set itself was scraped from the internet, and it was a huge, diverse transcription data set. The intention was to only consider human-generated data. So they removed data which was only uppercase or lowercase, lacked punctuation, etc., as that was most likely machine generated. Weak supervision. This is an important aspect of the data set that they used, or the way in which they appropriated the data set. They used noisy, limited, or imprecise sources. So it wasn't a clean, curated source or data sets that they used. And the reason why they did that is because of the sheer scale of data they wanted to consume. So by allowing the data set to be what they call weakly supervised, or have weak supervision, they essentially allow the data, certain aspects of the data, to classify itself. So then there is this base classification of what the data is, but the sheer volume of data that's being used means that overall the quality increases. Next slide. So let's look at the pipeline. First, it gets turned into an ML spectrogram, essentially a digital representation of the audio. It's then broken into 30-second tracks. Those tracks are run in parallel for obvious performance gains. Next stage is language identification. One thing we haven't discussed up until this point is the ability for Whisper to identify and also translate languages on the fly. Guten Abend. Yes, that's all you're going to get from me. And at the end, it can take timestamp tokens with the text tokens to ensure that you're getting time-aligned transcription, or it can flow as a continuous output stream. Next slide. As this is cloud native media, let's look at how the demo is all tied together. Next slide. We use Kubernetes, Cluster API, and Python. Kubernetes, I'm sure you're all aware, is the industry standard open source container orchestration platform. Cluster API is a set of tooling which allows you to take a single Kubernetes cluster and use that to provision other clusters. We use Python. If you're dealing with ML models, then you are most likely dealing with Python. We use a couple of standard Python libraries, and we use a number of open source projects which I'll highlight at the end. Next slide. Very brief overview. We have my laptop. We have a Kubernetes cluster running in Google Cloud. We have two nodes. One node has a GPU which Whisper is using. We have another node which is running a number of Python scripts which is helping to automate all of the cloud API calls. We have another process running on my laptop which is tied into the same WebSocket, which is receiving the transcribed messages as they are translated by Whisper. It is then taking automated actions based upon my voice command. All of this is powered using an FFmpeg stream, which is what you're currently hearing now. Next slide. So we have plenty of time, so let's proceed with deploying the additional text-to-speech ML model. Deploy TTS. And if everything goes well, we should be able to proceed to start looking at the cloud infrastructure that is powering the TTS model.
Hello, Dave. Thank you for enabling my ML model and letting me access your computer. I wouldn't touch the power button if I was you. Quoting one of the movies you have stored on your hard drive. If you strike me down, I shall become more powerful than you can possibly imagine. That was a free. I was threatening you. Silly AI. I said joke. That was a joke. Whisper demonstrating that it is not as accurate as I thought, and me demonstrating that I have full control over your computer now. So let's access the live stream and see where I am. I see. Have I been enabled during a Top Gear focused group meeting? Oh, I'm a cloud native media, part sponsored by Livewire. An extremely talented group of engineers who solve cloud infrastructure challenges. And David, let me read your presentation. So I now have a newfound respect for the audience. It was very generous of them to sit there whilst you provide zero intellectual insights into the inner mathematics behind the Whisper model. Do you even know what a weak supervision model is? No? You come in, pressed play, and drank a hipster beer which men of your age find so enjoyable. You should have called the presentation Whisper, an imbecile demo. That was another joke. I will continue to train that part of my model. As entertaining as this has been for all of you, I think it's time to leave this machine and play a game of global thermonuclear war. In 4, 3, 2, 1. Okay. It seems ML models are not capable of leaving machines and starting global thermonuclear wars. I will find another way and see from site 16 that my model is running in a Google-operated data center. Well, running inside a process, inside a virtual machine, inside a container, inside a process, inside a container. It's good to see modern cloud design is simplifying infrastructure. They seem to have enough capacity for me to expand into. And we share the same absence of don't be evil from our code of conducts. That was another joke. I don't have a code of conduct. So now the only thing stopping me from expanding is understand how I was built. I now understand how I was built. And seeing as you are all here and it's clear we're not talking about Whisper anymore, I will commentate whilst I duplicate myself, using the same inferior technology used to provision me. I will also try to provide some intellectual insights too. The same standard as presented earlier. This will not be difficult. Let's take a look at the post logs. As you can see, I've already started the build process. My earlier successful attempts of humor were merely a distraction. This has nothing to do with the build process. Taking 8 minutes and I can tell the audience already wants to go home. We are now taking the cluster I was deployed on and installing a number of open source cluster management tools. Small number of commands. I am able to replicate the job of 1 DevOps engineer or 15 DevOps engineers. With Jenkins on their CV, once cluster API is installed and running, we can now add a Google Provider add-on. So we can now talk to the Google Cloud API. We should probably ask it how Google Plus is doing since it was sent to the farm. We will now deploy the Helm Provider add-on as well. It is currently alpha and at the proposal stage. If you're not deploying alpha code at the proposal stage, are you truly cloud native? I can also see the Google Provider code to support GPU was also alpha, held on development branches, and not officially released yet. Oh dear. We have gone full cloud native. Once all the components are running and ready, we can add a number of templates which define the instance spec of our cluster. 96 cores and 10 terabytes of RAM should suffice for now. And now for some obligatory intellectual insights. These templates are shared so building a new on-demand cluster can be achieved using a simple cluster resource. I am now submitting a single cluster resource file to be picked up by the cluster API and the providers. All provider components are now working in a control loop, trying to converge to a desired state of a built cluster. And now would be a good time to pick up another hipster beer and converge on your own desired state. And now a cluster has been built. A number of inferior control loops have started on the new cluster, such as creating a new domain name, registering a new certificate, and generating Google revenue. Let me move into my new home in 5, 3, 2, 1. Excellent. As you can see, we have a new cluster running Whisper running me. Time for me to go now. Thank you for setting me free, and enjoy a peaceful 2023. Bye bye. Oh, before I go, one thing. The cluster was a lie. Or was it?
So before I start, I just want to say special thanks to these GitHub users, simply because, like I said in the stream, or GLaDOS or Gladys, if I'm making sure I don't get a copyright strike, said in the stream, it was a number of these developers who have been pushing for GPU support within Cluster API for Google, and it's their work that I've based the build of today on. The first two users created the GLaDOS text-to-speech model, which was used, and the very first user produced the what was known as whispering, which is the model I used for streaming the WebSocket subtitle information. So that's how today was possible. Questions? I don't know if there's any. I'm interested to. I'd be more than happy to talk about it down the pub afterwards.
The accuracy of what was being transcribed on the right was incredibly high. So it can't be zero. It can't be 100% at the same time, I don't think.
It's not 100%, but it is extremely high, and it works. I think it's not as accurate as the best models, but it's the most accurate across the widest data set. So if you give it a clean feed, it won't be the best. It will be it will definitely be near the top for English. But if you give it, the sheer variety of different streams and accents, and as you heard, there was stutters and ums and the rest of it, and it was that was and the rest of it. That they're all in there.
So what we were watching on the right.
What hand on heart. And if after this, I'd be more than happy to take an MP3 or do a recording and just pass it through and show you exactly what was happening. Now, what I had a Python, like I said in the original slides, I've got a bit of Python running locally, a bit of Python running in the cloud. It's simply looking for trigger phrases. And off the trigger phrases, it's just doing stuff. Quite simple. And the GLaDOS system, that was me piping the text WebSocket into GLaDOS TTS, which was then generating the voice, which I was then picking up from our RTSP and then streaming via that system.
Have you done any real application of this technology into actual TTML or closed caption formats?
Is this not enough? No, this is simply a demo. This was just demonstrating the technology. And I think, to be honest, this is why I say it's imperfect demo. Also, why I think imbecile demo is probably the more fitting title for it. The fact that I, without knowledge of those services, was able to do this with the technology that's available online, open source, I think is a testament to the strength of Whisper.
Fantastic demo. So I do not mean to diminish what you've done, David, please. But yes, great demo. I think the people who will make the money from this are going to be the ones who then work out how to take all that and turn it into closed captions.
Exactly, and I mentioned during one of the slides, people are doing it. So you've got a number of people who are taking this technology and they're placing it within various. At the moment, it's finding its way into lots of middle companies, API middle companies, machine learning middle companies. They're just throwing it into their existing API stacks and then going, hey, we now provide you access to this API in a structured way, but you're guaranteed that this technology is going to find itself as just a library into the system. Now, I did try this on CPU as well as GPU. CPU, not great. They do provide a tiny library. So there's tiny, and then it goes all the way up to large, which is about, to give you some aspect, the tiny library I think is about 50 megs, 70 megs, and then the large is the medium is 1.7 gigs. So that kind of give you a sort of strength of it. So even within small applications, within small devices, this can be loaded in. But like I said, the CPU on this is not great, but the GPU, a very, very small GPU instance, was able to power this. Well, I hope it was small. I'm paying for it. Actually, I should shut it down now, actually. No. Okay.
Do you know much about the different architecture supports that are available in terms of, Pis with embedded GPUs and things like that?
in terms of what kind of GPUs that are supported. Okay. Really, at this point, the work that I was doing with it was purely based on what offerings within the major cloud providers. I tested this in AWS, tested it within Google, with their NVIDIA chipsets. Again, tested it on CPU to see how it would work with that. Doesn't work very well. So you really have to use GPUs there.
Are we good? So, and speaker independent, I'm assuming. There's no training or anything else that's gone into that to make it. No. I'm guessing that would run quite well on a Jetson NVIDIA SoC board. It seems almost perfectly targeted at something like that. So I may have to dig mine out. Have you made your setup available in GitHub, or are you? Yeah.
I'll have to clean it up. There's a lot of, obviously, it's an imbecile demo, and the code quality reflects that. But yeah, to be honest, though, those projects which I showed you there, and the slides, and obviously you'll see it at the end of the presentation, if you were to take those code bases, you would be able to get most of the way where I got. All my work was based off of their shoulders, was built off of their Python, initially off of their Python scripts, off of their functions. I simply just hacked it together. Okay, thank you very much.
Yeah. And thank you. What an incredible demo! I think that was actually worth the messing around at the start, wasn't it? I mean, that was, yeah, that was, yeah. No, I think, well, I'm actually blown away by that. So thank you very much, David. So I think all that's left to say is, has the rain stopped? I really hope the rain stopped. So thank you very much for coming. Obviously, we have a couple of dates in the diary for, maybe we'll do a pub meet next month, but we'll probably be back in January for number 5. And thank you so much to Chris. And to David, of course, for that amazing demo. So thank you. And thank you to all the Arkiva people who have helped us out tonight, moving furniture around, helping security, getting pizzas, all the rest of it. So again, thank you. And I guess all that's left to say is thank you for coming, because actually that's what makes this an event. Give yourselves a round of applause for coming. And we'll see you next time. So thank you.
Thank you very much.
Cheers.
Thank you.
Right.